Hi everyone, welcome to my channel Data Labs. I'm your host and host Madhur. In this video, I will be explaining you the concept of data normalization. We will also cover forms of data normalization and also understand its benefits. If you are new and want to understand the basics of DBMS, you can follow the video Introduction to DBMS. You can find the link to the session in the description of this video. Let's begin. What is data normalization? Data normalization is a process followed while designing or modeling a database where we decide what tables needs to be created and what information will they hold. Aim of data normalization is to organize data within a relational database by breaking down larger unorganized tables into smaller well-structured tables which are further linked together using relationships. This process improves the overall quality of the database by reducing the data duplication and ensuring that each piece of information is stored in one place only. Hence, we also maintain data consistency and integrity. We have four main forms of normalization: first normal form, second normal form, third normal form, and Boyce Codd normal form. Now, let's understand first normal form. While following the first normal form or 1NF, we need to ensure that each column in a table contains only atomic values, that is, only a single indivisible value. We need to eliminate any repeating groups if there are any, such that no row has multiple values in a single cell. As you can see in the example table over here, the unnormalized student table has multiple values for the attribute course, which is not as per the 1NF. To convert it into 1NF, we will have to split the courses and add them as different rows, as you can see in this normalized table here. Let's move next to second normal form. In second normal form or 2NF, the data should be following the first normal form and it should remove any partial dependencies. Each and every attribute in the table should be fully dependent on the primary key only. Let me explain the partial dependency with the example here. The book table here is following 1NF, but it is not following 2NF, as there is partial dependency on primary key. The primary key in this table is order ID and book title. Now the author information relates only to the book title and not the full primary key. This is the partial dependency. To make this scenario meet 2NF, we'll split this table into two tables, order table and book table. The book table contains only the information about a book, and the order table holds the information which order ID corresponds to which book. Next, we will go through third normal form. In third normal form, 3NF, the data should be following 2NF and it should remove any transitive dependencies if there are any. Let's take an employee table which stores employee details like employee ID, employee name, department, project, and project duration. Now here the primary key is employee ID, as the employee ID will always be unique. But if you see, there is a transitive dependency. The project duration column is not dependent on the primary key column employee ID, but on another primary key column project name. We also see here that we are able to find two sets of entities in a single table. First is employee and second project. So we split this table into two tables, employee details and project details. Now to get the information about which employee is allocated to which project, we create a third table where we just have employee ID and project to give us project allocation information. And now we get third normal form. Other than this, we have higher normalization forms like Boyce Codd normal form, wherein we remove functional dependencies. We also have fourth normal form and fifth normal form. We hardly normalize the tables to these normal forms, so I won't elaborate much on them. The more the normalization we do, the more we split the data and hence keep on adding complexity for retrieval. More normalization also results into lower performance. So normalization done in real world scenarios are max 3NF or below. Now let's see what benefits we get by normalizing our database. First, the data storage becomes efficient as the data is stored in an organized manner. So the data retrieval also becomes simple. And also the update issues are minimized due to the decrease in data redundancy. As I already mentioned, we shouldn't normalize a database much as over normalization leads to complexity. We need to maintain a balance between normalization and performance. That brings you to the end of this session. I hope you found it useful. We'll come up with more interesting topics and tutorials about data. Please like the video and subscribe the channel. It keeps us motivated to create more such content for you. You can also comment in the comment section below for any questions or suggestions. See you next time.